Hi, my name's Rob and I'm the Technical Director here at Raptor Aerospace. I'm really excited today to introduce you to the ESERO Cansat Competition. The Cansat Competition is a fantastic way for you to learn about space and about electronics, about rockets and about coding and all kinds of wonderful things that you can use for engineering. It's what we would call an analog for a space mission, which means you go through the same processes that you would if you were doing a real space mission and designing a real satellite to go to space. And I think if you have that approach to it, it's going to be really fun and you're going to learn a lot. This is the kind of Cansat that you might build. So there's a tube, a long tube, and into this tube you need to fit all your subsystems and everything that is going to power your Cansat and provide its functions and its communications. Nothing can stick out of that, okay? At one end you've got an eye bolt that's for the recovery, and so you're going to have your chute attached to that. So here's your chute, and this will be all nicely wrapped up like that. Of course, when you're building it, you take off one end, and it's open like that, and then you've got these two rods that you can use to attach what we might call a sled. You can put your electronics on and attach the batteries and all kinds of things like that. And then the lid just goes on like that, fits snugly. You put some bolts on there, and then the Cansat is kept together under compression like that. So the UK Cansat competition is part of an international competition with ESERO-UK running the UK version. The winner of the UK competition can go on to compete in the European competition. The Cansat competition will consist of 5 phases. I'm going to tell you a little bit more about each of them just now. So the team should be between 4 to 10 members, and you need to have a tutor with your team. At least 4 of the team members need to be over 14 years of age, and 50% of the team must be citizens of an ESA member state, of which there are 22. Tutors will have access to ESERO workshops during Phase 2. And during Phase 3, you'll be required to provide progress reports and a final report. You'll be given all the details of that once you've registered with ESERO. If you want to make it more like a real space mission, then you could follow the kind of organizational and planning structure that a real space mission would. And this means just treat your reviews like project milestones that would occur in real space engineering. And these would be things like the preliminary design review, PDR, critical design review, CDR, flight readiness review, FRR. You can follow all kinds of systems, but if you'd like to do some of your own research into how real space missions are organized, you can do a Google search for things like NASA Systems Engineering Handbook, and you'll find things there like timelines of mission planning and engineering planning. And here you can clearly see PDR, the CDR, and the FRR. And remember, the milestones are just for you to review your own work, agree between the team that you've completed it, and make sure that everything is okay for you to progress on to the next stage. The dimensions of your Cansat are really strict, and you've got to build your Cansat accurately to these dimensions, otherwise it's not going to fit into the payload bay of the rocket. That's really important. So you can design your Cansat to do lots of different things, to do different kinds of experiments, but at a minimum, you need to be able to design it to take temperature readings through a thermistor and pressure readings through a pressure sensor. And these sensors are going to be connected to the Arduino, which is the brains of your satellite, your Cansat, and that's going to involve some coding. The data needs to be transmitted to some kind of ground station, which is likely to be your laptop. In terms of the weight of the Cansat, it needs to be a minimum of 300 grams and a maximum of 350. If it weighs less than 300 when you've finished it, then you need to add some kind of ballast in order to make it weigh a little bit more. Your Cansat can't contain anything that's going to set on fire and be dangerous, so it can't include any explosives or detonators or something particularly flammable. It's got to have power, so you need to find appropriate batteries which are going to do the job and provide the right kind of power for the things that you need. And the batteries have probably got to be accessible so that you can change them if necessary. And you should bear in mind as well with the power requirements that it may be switched on and standing for a while before your payload is actually launched. Through Raptor's involvement in many ESERO competitions, we've seen lots of failures over the year and things that have gone wrong. So I thought that I'd just try and tell you a little bit about some of them right now. Some of them are going to seem really, really obvious, but it's just worth saying really obvious things just to make sure you haven't forgotten anything. So one of the most basic factors that your Cansat works is making sure that nothing is protruding from the Cansat, so nothing is sticking out, so that the caps at either end fit and that nothing is sort of protruding. It's possible that there'll be a little bit of delay for the launch. It varies, so it depends. You might have to wait for the wind to die down or something like that, and so it might be sitting in the rocket for a little while. So you've got to turn the power on before that point and leave it. You're sort of away, distant from it. So what's going to happen during that time? Make sure that your power system is sufficient, that it's going to last, and that it's going to last more than just those few minutes. Make sure that you can access the batteries, so they need to be securely fastened so that they're not going to be bouncing around inside the Cansat, because that will damage your Cansat and could make the flight unstable. But at the same time, you need to be able to change them if you have to. Your Cansat also needs to have a master switch so that the whole thing can be turned on and off. So you should also think about how reliable the electronics are. Are there any connections that could come loose? Any weak soldering joints that might break when exposed to the high G loads? Not just at launch right at the start, but also when it's ejected from the payload bay after apogee. What about the parachute and the descent rate and the recovery? Okay, so you've got to think about if it's coming down really, really slowly. So if you use a chute which is too big and it gets captured by the wind, it's possibly going to travel a really long way. So you don't really want that. You want a chute which is an appropriate size. There's lots of ways to calculate that, and your tutor can help you with that. There are also online resources to be able to help you calculate that. How strong is the parachute attachment, and is that going to be a problem? So there's something that we call shock attenuation, which means something to limit the kind of really hard pull on the parachute cord as it opens. And so there are various ways of doing that, and I suggest that you Google that and you look up some of the different methods of doing that, and you include that as well, because that will help protect your payload. So you want to think about how you're going to find it after it's landed. It might be good to have some kind of radio beacon that's going to transmit to your ground station so that you can go and find it easily. Or you can even just have something really basic like a beeper thing that's going to make a noise, so that if it's in the undergrowth somewhere, you can at least hear it before you can see it. Think about what you need to operate or test or kind of verify that your Cansat switch is on and is going to work. So if you're in a field and it's a bit wet and windy, don't assume that you can use your laptop as freely as you can in your school or home. So make sure that if you need to use a laptop that it's got sufficient battery power. There's something we call the window test. So if you dropped it from a first floor window and it landed on the ground, is it going to break? If it breaks, you didn't build it strong enough. So that's a good thing to test sometime before the launch, so that then you kind of rebuild and make some repairs and adjustments to your design if you need to. Think about bringing some sort of spares and tools with you as well. So if something does go wrong at the last minute, that you can just do a quick repair, okay? Think about what those sort of failures might be when you do the final tests. Think about what tools you need to pack, make a list before you go, and make sure that you've checked it. The Cansat needs to be sort of designed to survive the launch loads, but as you're about to see in a moment, that's not the harshest point of the flight. So if you make it to the final of the Cansat competition, then you're going to be lucky enough to have your Cansat flown an orchestral rocket by Raptor Aerospace. So I just wanted to tell you a little bit more about what will happen during the flight and the kinds of things that your Cansat should be designed to withstand. So there's likely to be a pre-launch hold of around 5 minutes. Again, as I said before, this can vary because we might be waiting for some gusts of wind to abate before it's launched, or there could be some other reason why it gets delayed. And then there's a powered boost phase. This is when the rocket motor is lit, and there's very, very strong accelerations, but for a very short time, so for sort of around kind of 1 to 2 seconds. During that time, it's going to reach an altitude of about 100 to 250 meters, depending on the weather conditions by the end of the burn. The forces experienced from the acceleration and launch will be around 8 to 12 G. Next, there's a coast phase up to 8 seconds where the rocket will be gradually decelerating before it reaches apogee. And it's just after apogee where the ejection of the Cansat occurs. The rocket will be descending under its own parachute, and the Cansat will be descending under its own parachute. The ejection is the moment of highest stress on the Cansat. Your Cansat will then just be descending under its own chute, and you'll be able to go and recover it. So I hope that this little introduction has given you an oversight of the ESERO Cansat competition and introduced you to the challenges and the excitement that the competition holds. Good luck with all your projects, and we hope to see you at competition soon.